Okay guys, good afternoon, evening, or good morning, whichever applies to whenever you happen to be watching this video. Uh, this particular video builds off of the last one that you saw where we were solving linear equations. These skills that we're going to be applying next here are where we're trying to solve an equation for a particular variable. This is something that we do a little bit of in math, but is actually a much more useful for you in science classes where you have a lot of equations or a lot of formulas that have quite a different number of variables, but you might only be looking for one of them. So knowing how to rearrange an equation algebraically before you actually substitute numbers can often be a lot easier than doing math once you substitute values into it. So that's the whole point of being able to do this particular skill. So pay attention to what we're talking about here. If there's a greatest common factor, make sure that you factor it out, especially if that is the variable that you're trying to solve for. So let's take a look at our first example here. We have some equation, s is equal to p minus p times d, and they're saying that this is some kind of a retail formula. What we're trying to do in this case is solve for p. Now you can see on the right side of the equal sign, we have two terms that both have the variable p in it. This is where that first note that you saw on the previous slide was saying if there is a common factor between the terms, factor it out. In this case, p is common between the term here that's just p and the term that's p times d here. So when I factor that out, I'm going to get s is equal to p, and in parentheses, 1 minus d. And by factoring it out, we've kind of isolated the number of variables of p in the problem. We've taken it down from 2 to 1, which is really what we want. We only want one of them if we're trying to solve for it. So at this point, we would read it as s is equal to p multiplied to whatever 1 minus d would wind up giving you. So since p is what we're trying to solve for, we need to get that all by itself. And it's multiplied to the difference of 1 minus d. So at this point, since it's multiplied to the difference of 1 minus d, I'm going to divide by that expression, 1 minus d, on both sides of the equal sign. And here, the parentheses in the denominator aren't necessary, but if you'd like to include them, it doesn't change anything. But some people might like it just to keep things looking the same. So anytime I divide by something by itself, they always simplify to be 1. So by dividing the expression on the right by the stuff in parentheses, 1 minus d, we've simplified it to just be 1, which 1 times p doesn't change the value of p, and that's how we wind up with just p by itself on the right side. And on the left side, we're left with s over 1 minus d, and this would be our final rearranged equation, where we've solved the equation for p. So moving on here, this is going to be the one from experience is probably going to cause you the most types of problems because the variable that we're looking for in this case happens to be p with a subscript of 2, which I'll just say p of 2 or p sub 2, something like that. Since we're solving for p sub 2, what we're trying to, and it's in the denominator of the left side of the equal sign, if we're solving for an equation, we cannot leave it in the denominator. We absolutely have to take it out of the bottom part of a fraction. So I'm going to just rewrite the problem here because the text is kind of in the way. So I'm going to say c over p sub 2 is equal to p sub 1 over d squared. And we're going to get this p sub 2 out of the denominator by multiplying in the numerator on both sides of the equal sign. And so here on the left side, if I have a p sub 2 in the numerator and a p sub 2 in the denominator, those simplify to just be 1. And that will give me c is equal to p sub 1 over d squared times p sub 2. Now you could write it as like this. I could write it p sub 1, p sub 2 over d squared, but I want to keep it separate for demonstration purposes because we're trying to get the p sub 2 by itself. So we want to get rid of everything that's not that, or that's not the p sub 2. So at this point, the reason why I want to keep it looking like this is so that way you guys can clearly see what I'm going to do. So I'm going to just rewrite the problem one more time. C is equal to p sub 1 over d squared times p sub 2. So here I have a fraction, p sub 1 over d squared, that I have to get rid of. If I want to get rid of a fraction to move it across to the other side of the equal sign, what we do is we're going to multiply by its reciprocal. So d squared over p sub 1. And we're going to multiply that on both sides. Oops, I wrote that upside down. D squared over p sub 1. So here, p1 here and p1 here simplify to be 1. D squared and d squared simplify to be 1. And all I'm left with is p sub 2 on the right side of the equal sign being equal to d squared over p sub 1 times c. And you can write it like that, or you could write it as c d squared over p1 equals p2. Either way would be perfectly fine. Third example, this is a formula going back to geometry where in this case it's asking us to solve for the height of a particular trapezoid. So this one is a relatively easy equation. There's only about 2 steps that it's going to take us to solve it. But what we want to do, since we're trying to isolate this h, we have to get rid of the 2 here and the expression in parentheses where I'm adding the 2 bases together. So the first thing we want to get rid of, as far as trying to isolate our variable, is let's get rid of this 2 that's on the bottom. So everything in the numerator is being divided by 2. So if I want to get rid of it, I'm going to do the opposite of divide by 2, and I'm going to multiply both sides by 2. So here on the right, 2 divided by 2 simplifies to be 1. And I would wind up with 2a is equal to h times base 1 plus base 2. And at this point, we're at a point very similar to what we saw in the first example. The variable that we're trying to solve for is the height. We don't want to distribute it into the parentheses because it's already almost isolated by it's just one h. There's no more h's anywhere inside the expression on the right side of the equal sign. So since the height is being multiplied by the sum of the 2 bases, we're going to divide by the sum of the 2 bases on both sides. And again, if you'd like to, just for visual purposes, if you want to keep it in parentheses, you're more than welcome to, but it's not necessary. So here we're going to take the sum of the bases, and on the right side, anything divided by itself always simplifies to be 1. And on the left side, there's nothing top to bottom that could simplify. So I would be left with 2a over base 1 plus base 2 being equal to the height. And our fourth and final example here is an equation involving, I'm not familiar with it, but I'm going to assume that g is gravity and v is velocity and t is time. So this is something to do with maybe something falling, being affected by the force of gravity. So I could be completely wrong, but that's just a guess. Here we're trying to solve for g, which I'm going to assume is a variable representing gravity. And if we notice here on the right side of the equal sign in the expression, we have 1/2 multiplied by g, which is multiplied by t squared, and then we're adding the product of v times t. Now when we're solving an equation, typically we kind of work our order of operations backwards, meaning that I usually take care of any addition or subtraction first before I take care of any addition or multiplication or division. So it's kind of like doing our order of operations backwards. So since I'm trying to get this g by itself, and it's ultimately going to be added to this other product here, v times t. We want to get rid of that by using our opposite operations. So here, v times t minus v times t, that cancels out and makes 0. On the left side of the equal sign, they're not like terms, so I'm going to write it as the expression s minus v times t. So that'll give me s minus v times t being equal to 1/2 times g times t squared. Now at this point, technically all we have to do is one more operation, and we can do it at the same time, but I'm going to do it into 2 steps simply because we have that fraction. The 1/2 is really just a number, and it's being multiplied to g, and the t squared is really just a number, which is also being multiplied to g. That means we can get rid of both of them at the same time by dividing both of them at the same time. But I know that fraction might throw some people off, so I'm going to work with the fraction first and foremost and get rid of that. And as we saw in the last, or one of the previous problems, if I want to get rid of a fraction, I wind up multiplying by its reciprocal. So 1/2, the reciprocal is 2. So 1/2 and 2 simplify to be 1. And here I don't want to distribute on the left side. I just want to keep it as 2 parentheses s minus vt. And now it's going to just be equal to g times t squared. And since we're one step away from getting g by itself, we have to get rid of the t squared. And since it's multiplied to what we're trying to solve, we're going to now divide both sides by t squared. So here on the right side, t squared over t squared simplifies to be 1, which gives me g to be equal to 2 times s minus vt over t squared. And that would be the final rearranged formula. So we really need to have an understanding of when it's appropriate to use our opposite operations. When do I get rid of something through addition or subtraction first, like we saw in this problem? When do I want to get something out of a denominator, as we saw in a previous problem? But it's really just, this is algebra almost in its purest form, where we're just using our opposite operations in order to isolate a particular value. So that's all we're talking about here for literal equations. Hope you guys are taking good notes, and we'll see you in class soon. Thanks.